All right, so from here, we're now going to be talking about half-lives. Half-lives are typically used in chemistry. So for example, a radioactive particle, the reason it's radioactive is because it expels usually electrons or neutrons or protons out of its nucleus or just its atom. The problem is that it is entirely random, so you can't predict how long it will take one particle to disperse. Rather, you can calculate how long it will take for half of the amount to disappear. So half-life can be measured based on this formula. So I'm going to mark it as NF, which is going to represent your final value, NO, which is going to represent your initial value, times 1/2 to the power of T, which is the time that it takes to the time that you've observed it, divided by H, which is going to represent the half-life, or how long does it take for half of this substance to be disappeared, I guess. So let's say the question that I have available here is the half-life of a certain substance is 50 years. So let's start with this. Half-life is equal to 50. You start off with 12 grams. So our NO, or our initial value, is equal to 12. How much will be left after 75 years? So our time in this case is going to be 75. Okay? Now we don't know how much is going to be left, so we can mark that as a question mark. So I would rewrite the equation as NF is equal to 12 times 1/2 to the power of 75 divided by 50. Okay, so first we can solve that. We can rewrite this as NF is equal to 12 to the power of 1 or times 1/2 to the power of 1.5. Okay, so 1/2 to the power of 1.5, I will do that on my calculator. 1/2 to the power of 1.5 is going to give me 0.35, roughly. Okay, so I'm going to do 0.35 times 12, which will give me 0.35 times 12 is going to give me 4.2. Okay, so that's saying after 75 years, you will have 4.2 grams of this substance left. Now, another question that you might see is how long will it take for there to be 1 gram left? So in this case, this is a bit interesting. I'm going to erase this for the most part. We're going to keep the other values the same, meaning that our NO is going to be 12. Our time, we don't know. The half-life is still 50, but this time we have the final value, which is 1. So we can rewrite the formula out as much as we have. We have 1 is equal to 12 times 1/2 to the power of T divided by H. Divided by 50. Okay, so here's where things get a bit complicated. Personally, we want to get T by itself. So what I'm going to do first is I'm going to get rid of the numbers that I know I can get rid of. So I'm going to divide both sides by 12. Cross this out. Now 1/12, do that on my calculator because I can't remember off the top of my head, is equal to roughly 0.083. Is equal to 1/2 to the power of T divided by 50. So there's a couple ways we can do this. Personally, I would want to raise both sides to the power of 50. So if I multiply this by 50 and I multiply this, or raise this to the power of 50 as well, these two are going to cancel each other out. So then I have to figure out what the answer is raised to the power of 50 which is a very, very small number. So it's going to be roughly 0. Or we can even just keep it for now. Let's just keep it log. We're gonna write this as a log, by the way. It just makes it easier. But these two are gonna cancel out. So I will rewrite this just so we're clear. So I'm saying 0.083 to the power of 50 is equal to 1/2 to the power of t. Okay, so from here, we want to get t by itself, so we're going to have to write this as a log. So I write this as log 0.083 to the power of 50 is equal to log 1/2 to the power of t. Now, I don't know if you've watched any of the other videos before you watched this, but you should know that there is the power rule when it comes to logs, which means that any marking at the front or any exponent can be brought to the side. So this will be 50 log 0.083 is equal to t times log 1/2. Now all we have to do is divide log 1/2 on both sides. I apologize, I'm running out of space. Now I will solve that here for you. So I will quickly do log 0.083 times 50. It's going to give me negative 54.046. Okay, now we're going to divide that by the log of 1/2, which will give me 179.53. I don't know if you can see that on my calculator. So that's saying, I'm gonna erase this just so you can see. I apologize for the size of my whiteboard. I am currently at my grandparents' and don't quite have my normal material. So I would say the time is equal to 50 times log of 0.083 times log of 1/2, which will come out to t is equal to 179.54 approximately. So that's saying it'll take 179.54 years for there to be only 1 gram left over. I hope this was helpful. Have a great rest of your day.